Hi, this is KMP algorithm. So in the string matching, we have North-Morris-Pratt's algorithm. This is previous algorithm. It is like it is shifting one shift if our pattern is not matching, and then we'll be shifting one shift. But using KMP algorithm, we can shift actually many shift. For example, in this case, till this it is matched only. This text is not matched, right? So based on this, now this A and B we no need to waste. So we'll be keeping this and then we'll compare other text. So this shifting is the difference from brute force to KMP. So here to how to shift that, for that we need to calculate a by function. So we have like this. So only for pattern we are calculating this. So in the KMP matcher, a compute prefix function, it will deal with only P of K plus 1, P of Q we are comparing, not the actual given text, only for the pattern we are computing by. So compute prefix function, it's like M equal to P dot length of the pattern. We are going to create a new array called by of 1 to M. By of 1 we are initializing as 0 and K equal to 0. For Q equal to 2 to M, we are calculating this one. So here k greater than 0 and uh, so for every iteration from q equal to 2 to m, initially I'm doing q equal to 2, so k is greater than 0. Initialization is 0, so it's not greater than 0, it fails, it is and condition. So if it is fails, we can remove this. So we are this while loop will not be executed. Then we need to compare if p of k plus 1 equal to p of q. In this case, k is 0 plus 1, which is p of 1 equal to p of q is 2. So in our pattern, we have first letter as A and second letter as B. So A not equal to B. So that means we can say like K equal to K plus 1. Okay, this will also fail. So if this condition also satisfy, then K will be increment, otherwise not. So by of Q, by of 2 is, by of 1 we have initialized as 0, by of 2 is K value is 0. So in here we are updating by of 2 as 0. Like this we are going to calculate by of 3. Again the same steps, the same algorithm we are writing, and we are replacing k and q values. So now again this p of 0 plus 1, p of 1 and p of 3, these both are matching, so k equal to k plus 1. If it is not matching, the k will be by of k. If text is matching, then k equal k plus 1. So now by of q equal to k. What is k? Is 1. So by of 3 equal to 1. So here we are updating by of 3 as 1. So likewise, we are calculating till by of 7. Only when q equal to 5 or 6, the while loop will be, both the condition will be satisfied and k will be by of k. In that case, by of 3, we already calculated 1. So we are updating here. And once this is done, we will be once the by calculation is done means, then we will compare our actual pattern with the text. So here, so in this case, when iteration third, that time our things will be matching, and when I equal to 9 also it will be matching. So in KMP algorithm, how much shift we are doing, from here it is starting. First one is prefix matcher. This is actually KMP algorithm. So n equal to t dot length, text given text length, m equal to given pattern length, and by equal to we have computed, and here we are initializing q is 0. So for I equal to 1 to n, that means from first letter to n letter in the given text, all the letters we are going to compare these things. If our pattern and text is matching, full length is matching, then we'll be telling that this shift is fine. It's our pattern. This pattern occurs with the shift. But here, if it is not the case, we'll be continuously verifying till n. So for example, if I equal to 1, we are right for every iteration we are writing this code, and then we'll be replacing the q values, and we'll check which step will be executed, like how we calculated I. So here q greater than 0, initially q is 0, so this will be fail, it won't execute. If p of 0 plus 1 equal to t of 1, our pattern first letter is a and our given text also a, both are matching, so q will be incrementing 1. Q is not equal to m, we have not yet matched the full pattern. pattern length is m, right? Just we started with the first letter. So okay, so likewise we'll be calculating for all the iteration, no? So now q equal to 1, first iteration. So in the first iteration q value is increased. We have started with q equal 0. In the second iteration q equal to 1. Whenever the given pattern, for example, pattern and this text is matching, then q will be q plus 1. If that is not matching, then q equal to by of q. So that is the trick here. So q equal to q plus 1, again 2. We can say like here AB A, only in this when sixth letter it is failing. Our pattern is not matching with the given text. So if we go and see, these are all by calculation. This is our actual matching iterations, right? So I equal to 2, q equal to increased. I equal to 3, q increased, q equal to 2. I equal to 4, q increased, q equal to 3. Because pattern is actually matching with the given text. So if it is matching, q value will be increasing. Q equal to 4, we can say. Q equal to 5. And then here, when we come to I equal to 7, actually it's not matching. Yeah, in I equal to 6, sixth letter was not matching, right? So here itself, it is not matching. If it is not matching, the while condition will be satisfied. So q equal to by of q. Q value is not increasing in this case. That means that we are saying here in this value, pattern is not matching. So q equal to by of 5 equal to 3. Q value is 5, na? By of 5. If we see our first by value, we have calculated here now. So yeah, by of 5 is 3. So we are updating q as 3. Yeah. And then since it is a while condition, once find also we need to try again. Q is greater than 0, which is satisfying. Q plus 1, now q is 3 na, so 3 plus 1 is 4. P of 4, our pattern 4 is whether satisfying with 6. It is actually matching. It is to satisfy this while loop, it should be not equal to q. So q this will not be executed. When we come here, whether q plus 1 equal to t of 1, that is also not t of I actually, that is also not satisfying. So we are dropping here. So now we are proceeding with the value. Okay. Since it is b equal to b, when pattern is and the given text is matching, q equal to q plus 1. In this while loop, this is increasing. In the first one, it is failing. Okay. So 4. So q equal to 4, we are proceeding with another. We are not actually shifting from first to second. We are actually shifting from previously 3 letters already matched. So we are using that it indicates. So now I equal to 7, while q greater than 0, yes, it is matching. And whether our pattern and t of 7 is matching, yes, it is matching. So if it is matching, q equal to q plus 1, that means q will be 5. And then again it will be matching pattern and t of q. So q will be increasing. And then here our pattern and t of text is not matching, so q won't be increasing. Q will be by of q. So now q value is actually by of 7 equal to 1 in our by function. If you see, by of 7 index equal to 1, so we are updating that one. So likewise, if we saw our given text is having I equal to 15, so if we solve for 15 iteration, so instead of writing code for all the iteration, we can say like, if it is matching, it is q equal to q plus 1. If pattern and given text t of I is not matching, then q equal to by of q. Okay, so when I equal to 11, actually it is matching our pattern and text. If we see here, this is the 11th letter, and here it is matched actually. A, B, A, B, C, A. So once if it is matched, we'll be like and then again A B C A, two occurrence we are finding. So that in that case we are updating like it is matching and Q equal to M. So eighth shift it is matching, so T of 9. In the ninth letter we are finding the match. Likewise previously in the one shift I think we missed, there it is matching, so we'll say like in when Q equal to 3 it is matched. Pattern occurs with shift I minus M, that will be executed.